Here we have x is equal to 1 minus t square upon 1 plus t square and y is equal to 2t upon 1 plus t square. Here we have common parameter t. So we have to differentiate our both equation with respect to t. So we will get dx by dt is equal to differentiation of 1 minus t square upon 1 plus t square. For that we have to apply division rule. First term, your 1 plus t square will be as it is. We have to differentiate 1 minus t square, which will be 0 minus 2t, minus 1 minus t square will be as it is. We have to differentiate 1 plus t square, so that will be 0 plus 2t whole divided by 1 plus t square the whole square. Now for simplification we can take minus 2t common from the both term. So from first term, remaining term is 1 plus t square plus from second term 1 minus t square whole divided by 1 plus t square the whole square will be as it is. So here t square will cancel out and we will get minus 4t upon 1 plus t square the whole square as your dx by dt. Now let's try to differentiate y with respect to t. So we will get dy by dt is equal to differentiation of 2t upon 1 plus t square. So we have to apply division to first term. 1 plus t square will be as it is. We have to differentiate 2t, which will be 2, minus your 2t will be as it is. We have to differentiate 1 plus t square, which will be 0 plus 2t whole divided by 1 plus t square the whole square. So for simplification we can take 2 common. So from first term, remaining term will be 1 plus t square minus t into 2t will become 2t square whole divided by 1 plus t square the whole square. So finally we will get 2 times 1, this t square minus 2t square will become minus t square upon 1 plus t square the whole square will be as it is as your dy by dt. So we are ready to get dy by dx, which is nothing but the ratio of your dy by dt and dx by dt. So here 1 plus t square the whole square will cancel out. 2 2s are 4. So we'll get minus this 1 minus t square and in denominator 2t will remain. Now our answer should be in terms of x and y. So to get proper term of x and y, let's multiply and divide by 1 plus t square. So 1 minus t square upon 1 plus t square will become your x and 1 plus t square upon 2t is reciprocal of y. So we get our dy by dx is equal to minus x by y, which is given in option C. Ta-da! Here you have to find dy by dx where y is equal to a raised to t plus 1 by t and x is equal to t plus 1 by t whole raised to a. Now we have x and y in terms of parameter t. So we have to differentiate our equation with respect to t. So we will get dy by dt is equal to differentiation of a raised to box. So differentiation of a raised to box is simply a raised to box into log a into differentiation of box. Within the box we have t plus 1 by t. So we have to multiply differentiation of t, which is 1, and differentiation of 1 by t, which is minus 1 upon t square. And from equation of x, we will get dx by dt is equal to, on right hand side, whole raised to a is your outer function. So let's consider box around the t plus 1 by t. So differentiation of box raised to a will be a box raised to a minus 1 into d by dt of box. Within the box we have t plus 1 by t. So we just have to multiply differentiation of t, which is 1, and differentiation of 1 by t, which is minus 1 upon t square. So we can say we are ready to find dy by dx by taking ratio of your dy by dt and your dx by dt. So here 1 minus 1 by t square will cancel out. So let's remove them and we will get our required dy by dx. Ta-da! In this question, you have to find differential coefficient of x raised to 6. Let's say it is u with respect to x cube. Let's say it is v. That means we have to find du by dv, and for that we have to differentiate our equation with respect to x. So from first equation you will get du by dx is equal to 6x raised to 5, and from equation of v we will get dv by dx is equal to 3x square. Now we know that du by dv is nothing but ratio of du by dx and dv by dx. So in numerator we have to substitute 6x raised to 5 and denominator substitute 3x square. So we will get du by dv is equal to 2x cube, which is given in option D. Ta-da! In this question, you have to find derivative of sine inverse of 2x upon 1 plus x square. Let's say it is your u with respect to cos inverse of 1 minus x square upon 1 plus x square. Let's say it is your v. Now, before we go for differentiation, let's apply the rules of inverse trigo. The sine inverse 2x upon 1 plus x square is equivalent to 2 tan inverse x. And similarly, cos inverse 1 minus x square upon 1 plus x square is also 2 tan inverse x. So we can say here u is same as v, but we have to find du by dv. So we have to differentiate our equation with respect to v. So we will get du by dv is equal to differentiation of v, which is 1, which is given in option B. Ta-da! In this question, we have to find differentiation of cos inverse of 2x square minus 1. Let's say it is your u with respect to cos inverse x. Before we go for differentiation, let's try to simplify our u. Let's assume your x is equal to cos theta, where theta belongs to 0 to pi by 2. So we can say your u will be cos inverse of 2 times cos square theta minus 1, which is actually your cos 2 theta. Now, cos inverse and cos are inverse function of each other. So we will get u is equal to 2 theta, or we can say 2 times cos inverse x. We already have cos inverse x is equal to v. So here we get u is equal to 2 times v. Now to get du by dv, we have to differentiate our equation with respect to v. So we will get du by dv is equal to 2, which is given in option A. Ta-da! In this question, we have x is equal to t raised to 8 plus 1 and y is equal to t raised to 10 plus 1, and we have to find d square y by dx square. For that, we have to differentiate both equations with respect to t. So, we will get dx by dt is equal to 8t raised to 7 plus 0, which we can ignore, and dy by dt is equal to 10 t raised to 9 plus 0, again which we can ignore. So we can get our dy by dx by taking ratio of dy by dt and dx by dt. So your numerator is 10 t raised to 9 upon denominator is 8 t raised to 7. So here 5 2s are 10, 4 2s are 8, and we will get t raised to 9 minus 7. So dy by dx will be 5 t raised to 2 upon 4. But as you can see, we need d square y by dx square. So no problem. Let's differentiate our equation with respect to x. So we will get d square y by dx square is equal to, this 5 by 4 is constant, differentiation of t square will be 2t into dt by dx. 5t upon 2 will be as it is. Now we have to substitute the value of dt by dx, which is actually reciprocal of dx by dt. So let's place the value 1 upon your 8t raised to 7. So here we'll get 5 upon 2 8s are 16, and you have to reduce 1 power of t. So we will get t raised to 6 is your d square y by dx square, which is given in option C. Tada! In this question, we have to find derivative of log sec theta plus tan theta with respect to sec theta at theta is equal to pi by 4. That means, first of all, we have to find out du by dv and then substitute the value of theta. And for that, we have to differentiate both equations with respect to theta. So we will get du by d theta. In right hand side, your outermost function is log. So we have to consider box around the rest of the function. That means we have to differentiate log box, which is simply 1 upon box d by d theta of box. Within the box we have sec theta plus tan theta. So we have to multiply differentiation of sec theta, which is sec theta tan theta, plus differentiation of tan theta, which is sec square theta. So from numerator, if we take 1 power of sec theta common, we will get tan theta plus sec theta upon sec theta plus tan theta will be remain as it is, and they will be cancelled out, and we will get du by d theta is equal to sec theta. Now let's try to get dv by d theta by differentiating our v with respect to theta. So differentiation of sec theta is simply sec theta tan theta. So we are ready to get du by dv, which is ratio of du by d theta and dv by d theta, which we already find out. dv by d theta is sec theta and your dv by d theta is sec theta tan theta. So sec theta will cancel out and your du by dv is simply reciprocal of tan theta, which is cot theta. But we need our du by d theta at theta is equal to pi by 4. So let's substitute theta is equal to pi by 4. So your du by dv at theta is equal to pi by 4 will be cot pi by 4, or we can say 1, which is given in option B. Tada! In this question, we have x is equal to a cos cube theta and y is equal to a sin cube theta. and we have to find 1 plus dy by dx the whole square. Your x and y are dependent on parameter theta. So we have to differentiate both equations with respect to theta. So we will get dx by d theta is equal to a is constant. To differentiate cos cube theta, we have to consider box around the cos theta. So we'll get differentiation of box cube, which is 3 box square into d by d theta of box. Within the box we have cos theta, so we have to multiply differentiation of cos theta, which is minus sin theta. And from equation of y, we will get dy by d theta. A is constant. To differentiate sin cube theta, we have to consider box around the sin theta. So differentiation of box raised to 3 will be 3 box square into d by d theta of box. Within the box we have sin theta. So differentiation of sin theta will be cos theta. So we are ready to get dy by dx, which is ratio of your dy by d theta and dx by d theta. So here 3a will cancel out, 1 power of sin will reduce and 1 power of cos will reduce. So we'll get minus sin by cos, or we can say tan theta. But if you remember, you have to find out under root of 1 plus dy by dx the whole square. So let's substitute the value of dy by dx, which is minus tan theta. So we will get under root of 1 plus tan square theta, or we can say 1 plus tan square theta is sec square theta. So here we have under root of whole square, so we will get mod sec theta, which is given in option D. Ta-da! Here we have x is equal to a sin theta and y is equal to b cos theta, and we have to find d square y by dx square, and for that let's differentiate with respect to theta. So from equation of x we will get dx by d theta is equal to a, differentiation of sin theta will be cos theta, and dy by d theta will be b, differentiation of cos theta is minus sin theta. So we can get dy by dx by taking ratio of dy by d theta and dx by d theta. So your numerator is minus b sin theta upon denominator will be a cos theta. So we will get dy by dx is equal to minus b by a. Your sin theta by cos theta will become tan theta. But as you can see, we need d square y by dx square. So let's differentiate our equation with respect to x. So we will get d square y by dx square is equal to minus b by a is constant, we don't have to worry about it. Differentiation of tan square theta will be sec square theta into d theta by dx. To get the final answer, we need to get value of d theta by dx, which is actually reciprocal of dx by d theta. So rest of the terms will be as it is. Your d theta by dx is actually reciprocal of your dx by d theta, which is a cos theta. So we will get minus b by a square into sec cube theta as your final answer, which is given in option C. Ta-da!